Once your chemotactic is over, then you go to the reproduction. How do you decide reproduction? Here you have 10 bacteria. For each bacteria you have how many cost function? Cost value, not cost function. Suppose 10 bacteria are there. How many cost value you cost? 10 cost. One bacteria is going 5 chemotactic. So how many cost you will get? When the bacteria is in first chemotactic, you will get one cost. When the bacteria is in the first bacteria is in the first chemotactic, you will get one cost. First bacteria in the second chemotactic, you will get another cost, because it is a new value. Whenever your parameter is changing, you will get a new value, na? So first bacteria, first chemotactic, one value. Second, another value. Third, another value. So like that, if you are having 5 chemotactic, 5 values of cost for first bacteria, 5 values for second bacteria, 5 values for third bacteria. Now, which bacteria is successful? In case of GA, you were getting one value for one chromosome. Chromosome number 1, one value. Chromosome number 2, another value. So you were able to do the survival of the fittest. But now bacteria number 1 has 5 value. Bacteria number 2 has 5 value. So which is a stronger bacteria now? Which will give the maximum food. No, I am minimizing. No. Bacteria number 1 is having 5. Bacteria number 2 is having 5. Bacteria number 3 is having 5. So which one is the strong one?
Every bacteria you have to find out minimum.
Yeah. So that is the one that I have proposed. This one has recently published in IEEE transaction. You have read that paper, hopefully. Okay. So, Achha, you are working on that? Achha, you are under Professor Patnaik? Okay. Right. So, there may be two set of approach for this one. One is, you think that bacteria number 1 has taken that amount of food. In the first chemotactic he is eating something, second chemotactic he is eating something. So the amount of food one bacteria is eating, he is definitely stronger. So add all these chemotactic values. Bacteria number 1, first, second, third, fourth, 5. Add all these. So he is eating that amount of food. So whatever value you will get, that is, let us assume that the strength of that bacteria. Similarly, you found for second, third, fourth, like that. And you decide now which is the strongest. But it had some problem. Basically, this was proposed, maybe from the medical point of view, I don't know, because it seems logically okay, that if I am taking more food means I will be more stronger. Okay, but I found one problem when I am exactly applying this to the engineering group. What happened? Suppose I am going for a minimization and let me have 3 chemotactic for a simplification. And there are suppose 3 bacteria, 1, 2, 3, and this is having 1, 2, 2, and I am going for a minimization. Remember, I am going for a minimization, so I should consider the minimum bacteria, the bacteria having minimum amount of food. Okay, so 1, 2, 2. Next one is 0.5, 4, 5. Then this is suppose 3. This is 2. Okay. No, sorry. This is to 5. This is 5.5. Right. Okay. So suppose there are two bacteria. One is 122 and another is 0.532. If I am going by the food concentration, then which bacteria will be strong? First one is 5, second one is 5.5. So I will suggest consider the fifth one, the first one, right? Now this first one is having some parameter here, some parameter here, some parameter here. So which parameter you will take to the next generation? I am choosing that bacteria number 1 is the strongest one. That's right. But I have to pass the parameter. I cannot pass all the parameters. I have to pass one parameter. So which parameter I will pass? I should pass this parameter, right? But I am discarding this one. In this bacteria, there is a value which is 0.5. So I am losing some information or not? Instead of choosing this one, I should have chosen this one, so that I could have converged quickly. Because this is less than 1. So this is better compared to 1. But if I am taking the average one, then I am losing that information. So I little bit modify the thing in the sense that I propose take the minimum of this set, take the minimum of this set, then you rank them instead of taking the average or summing. So if I am taking the minimum one, then I will definitely choose this point. I will not leave it. So once you take that, whether you, in my first paper it was basically summation. It was accepted in IEEE transaction evolutionary, where it was basically the summation one. But then I found this problem and again I proposed another one which is also accepted. Then here once you get the minimum values, then you go for the formation of your bacteria for reproduction. Arrange them in the ascending or descending order depending on whether you are maximizing or minimizing, and then you replicate the first portion with the second portion. Then this set, the new set which is coming, will be used for the next generation. Just like in GA we do, we go for repetition and repetition. Same thing here also. Whole thing will be now replicated. Okay, so this I have used for some of the applications which may be interesting for you. Let me discuss that applications. I have written applications to power system, but it is not power system, it can be a generalized one as well. I am having now a distorted waveform which is having a relation in its harmonic. We know from the Fourier series that if it is a periodic waveform and distortion is there, then we can find out its Fourier spectrum as well as Fourier series value. We know it. So, once you get the Fourier values, then I can represent any distorted waveform as Zt is equal to this one, where An is the amplitude of the nth harmonic, n is the harmonic number, phi n is the phase angle, and this is the noise. So, any signal Zt can be represented by this. Now, my issue is, if I am giving with a distorted signal and I took the samples, can I get these An and phi n? Yes or no? No. Then भाई ये हार्मोनिक एनालाइजर क्या कर रहा है? When I am purchasing harmonic analyzer from Fluke, it is giving me fundamental is this percentage. वो percentage में देता है, but anyway percentage and absolute, that is no problem. So generally we go by Fourier transform. Whenever we go for this type of activity, we go by Fourier transform. You take the samples, put it into FFT, and you get the amplitude corresponding to the fundamental and its harmonics, right? But there are certain problem in that. The problem is, if there is a noise in the signal, then the Fourier transform sees it as a frequency. It will give a frequency term in your FFT. So either you have to remove that term, or if you are considering that term, it will be erroneous. Your result which you will be getting, it will see a frequency in the particular component which is actually not there in the signal. Now the problem is, you don't know whether the signal is present in your original signal or not. That has come due to noise. But since you don't know, you will think that yes, this signal may be there, and all your procedure will may be wrong. Therefore, we need to take care of that issue. So I proposed the bacteriophoraging algorithm to find out the phi n here. The phi n I propose to find out from this expression. And once phi is found out, then I use the least square algorithm, which is generally the most common algorithm, for finding the amplitude. Okay. So I go in a iterative method, and finally I got the result for An and phi. And this is the paper in 2005, IEEE Evolutionary Companies. Okay. So you see, this is the procedure which I have adopted. This is my sample Zk at any instance k. This is the Hk, which is this matrix, because omega 1, omega 2 up to omega n are the harmonics. This is the amplitude A matrix, which is nothing but A1, A2 up to An, and this is the noise. So I am representing that in a matrix form. Now from this is the least square algorithm, this portion, which is very simple. If Zk is equal to H into A, then you put the pseudo inverse. You know pseudo inverse of a matrix? A matrix is there, and I told you to find out the inverse, and that is a rectangular matrix. Can you find out it? If it is a square matrix, you can find the inverse. But if it is a rectangular one, 3 by 4, you cannot find out. So in that case we go for pseudo inverse. 3 by 4 multiply by 4 by 3. So it becomes 3 by 3. So you can now find out the inverse. Okay. So that thing I have adopted here. And that is this is a quite general thing. It is not the thing that I have proposed. Okay. So you multiply by hk, that is h transpose. 3 by 4 should be multiplied by 4 by 3. So here I am taking transpose, then here I will put the transpose. So it becomes h transpose h. So A becomes h transpose h, this side you take this way, inverse into h transpose into z. Very simple. First you multiply h transpose both the side. Then left hand side is h transpose into z. Right hand side is h transpose h into A. Now what is A? H transpose h inverse. Z is equal to h into A. H transpose H transpose. Okay. Now I want to find out A. So what is that? H transpose H inverse H transpose Z is equal to A. Or not? I am first multiplying this one and now I am able to find out the inverse. So I multiply the inverse here. So this inverse, this into Z is equal to A. This is called as least square. Okay. So actually the proof is not that simple which I have done here. It is lot of other things are there. But this is a way that you can understand the thing. Okay. So here the issue is I should know H. Once I know H, I can do calculate A, because anyway the sample value is with me. Z is sample value which I have obtained from my signals. So since that is with me, if I can tell AH value to my system, I can get A value and I can simulate this signal. But at the first instance, when I am calculating the phi from a random set, my H will not be correct. So the A value that I am getting will not be proper. So when I am reconstructing the signal, that will not be exactly that of Z. So there will be an error. So my issue is, now I will go in an evolutionary manner to propose H and H in each iteration such that my error should go down and finally 0. When my error becomes 0, my estimated Zk and actual Zk is now matching. So that is the simple algorithm that has been proposed.